Hi everyone, I'm Amy,
And I'm Kelly.
and we are DSSG Fellows. We are partnering with Hong Kong University, the University Museum and Art Gallery, and today we are going to be presenting to you guys our project that we've been working on for the past 14 weeks, the AI Museum Tour Guide Assistant. So the overview of this presentation, starting off with a little bit more about our partnership and how that led to our project idea along with the demo, and then the technical implementation details, and finally the future considerations. So a little bit about the University Museum and Art Gallery, also known as UMAG. It's Hong Kong's oldest operating museum with over 70 years of history. They have a wide variety of exhibitions like Chinese, Western, and early Hong Kong art, and they are committed to teaching Chinese art and museum studies through tours and workshops. And they host permanent collection along with rotating exhibits. So they provided us 3 PDF booklets, one about ceramics, traditional paintings, and also silk. And each exhibit booklet follows the same format. There's an English version detailing the actual artifact along with the history, symbolism, whatnot, and then a Chinese translation version. And each artifact is displayed in the image like this. And so our tour guide assistant addresses UMAG's challenge of the difficulty and logistical struggle of planning tours. They are a smaller museum, so there is a lack of staff, and the staff range in skill level and experience level to accommodate for the various tours that are being held constantly. And so our project is a tool that supports these tour guides in efficient tour planning, and they cater using a survey to each of their assigned groups. And now on to the technical details. I'll pass it over to Kelly.
So before we can actually build our model, there's some additional data pre-processing steps we have to go through. So we're starting off with PDF data. So our data has images, it has text, captions, headers, but we're predominantly interested in using the text. So we're going to extract it and clean it because we're going to be using the English text for our project. And so we remove the Chinese text. Next, we go through a step called chunking. So this is where we break all of our text into smaller chunks. For us, we split it by artifacts. So each chunk would have a header, the images, and the body of text associated with that artifact. And then afterwards, each chunk will go through a process called topic tagging. So let me just explain it a little bit more. So the purpose of topic tagging is to improve our retriever steps later in our model. So what we do is we actually prompt an LLM. So we say, for this body of text, which one of our predefined tags best apply? So we worked with UMAG to develop different tags. So you can see the categories range from like time periods, the color, the material about the artifact. And then the LLM will return what it thinks applies to that text. So it might be something like the Ming Dynasty, Wu Chai, and like porcelain. So each of these chunks will go through topic tagging, and then we will convert it into a vector format, which is just a series of numbers, and put it into our database, or conceptually, you can think of this as a knowledge database. So now we have all of the information and facts about the museum and its artifacts in a format that the computer can understand and that our model will be using later.
Now I'll be going over our demo. So it starts off with the tour guide inputting their major background, selecting the specific exhibit along with the age group of the tour, and then also the subject or focus of the class that they're touring. And this is where the topic tagging comes in. As you can see, each category is a specific theme, and then within each theme, there's the different topics you can select from. And then there's an in-text field where you can input any more topics that you're interested in that wasn't addressed in these different categories. And then you can submit this form and select the duration and add any like additional notes. This can be accessibility or specific ways of like tone or framing of the tour. And this will generate an itinerary key talking points, and also engagement tips. Takes a little bit. And then here you can see there's an itinerary in 7-minute intervals, allowing for also the tour guide's personal reflection, as you can see here. And then there's the key talking points. So any significant history, symbolism is addressed here as well as the specific topics the tour guide inputted. And it also relates back to the tour guide's major and background as well. And the engagement tips is a section where it kind of guides the tour guide to frame the tour in a specific way, as well as key takeaways and creative activities suggestions. And so this is all built off of retrieval augmented generation, and this is also known as RAG. And this is a method that combines large language models with external data sources. So in our case, the exhibit booklets as well as the survey. And so what this does is improves the relevancy of the responses because it grounds everything with the external sources provided, as well as reducing hallucinations. So any false information or incorrect statements would be avoided. And then finally, it personalizes the entire tour based specifically in this case, the survey inputs, and improves the accuracy of the responses. And so Kelly will go more into detail about the pipeline.
So at a high level overview about what REG looks like in the context of our project. So first we have the survey inputs. So you would have the time duration, the age group, the interest that they put in. And this gets passed to a retriever. So the retriever is a tool that goes into our database and tries to find the most relevant chunks. So it will go look up and find chunks. And for example, these are examples of relevant chunks. And we can see they're relevant because of the keywords bolded. It mentions kingfisher, roses, about nature and the Qing dynasty, all matching what the user put in. And all of these relevant chunks are then passed to our generator, which is an LLM. So we use GPT-4o for our project, and it's passed with a set of a prompt, which is basically just a set of instructions telling it what you want it to kind of format. So if, for example, it could be something like generate a 45-minute museum itinerary for 8 to 10-year-olds, focusing on those themes. So what we've done so far is that we've passed it information about UMAG's exhibits and the artifacts. And then we also tell the LLM to kind of tailor it towards the audience, the class that's visiting. And from that, we're able to generate that personalized itinerary using specifically UMAG's artifacts. Next, I'll kind of go into a little bit more detail about our technical implementation. So the first step in our project is what we call a query rewriter. So what you have is that you have our survey inputs, which are just standalone words about their interests, but we want to convert it into a human readable form. So basically just a sentence. And the reason we do this is because the retriever is trained on natural language sentences. So we want to convert it into a form that it's going to be able to be most useful so that we're able to have a good performing retriever. And then next we have our retriever. So as a recap, the job of the retriever is to find relevant chunks. And this is important so that the generator can generate a high quality output or a really relevant and grounded itinerary. So we ended up using 3 different retrievers. So we have a semantic one, a keyword one, and then a tag retriever. So the tag retriever is looking at the tags that we use for our topic tagger in our pre-processing step. So this tries to see if the tags of the chunk match the tags that the user put in the survey. So all of these retrievers look at different metrics, and they're actually also scored differently. So what ends up happening is that you'll have chunks that are going to be ranked differently within each retriever, just because each retriever is looking at different components. So we need some sort of way to find out which chunks are most relevant. So we end up using is a reciprocal rank fusion algorithm. So this creates a score called the rank score. So this will look at the position of a chunk within a retriever. So for example, if we look at the semantic retriever, the green chunk or chunk 72 would have a high rank score because it's at the very top of the list, whereas the purple chunk or chunk number 2 would have a lower score for its rank score. So we do this for each of our chunks and for all of the retrievers, and we compute a rank ROF score. So this is just a weighted sum of the semantic rate score, the keyword, and the tag rank score. And this is able to help us produce one single merged list where we can just see which chunks are most relevant, considering all of the different components of semantic, keyword, and tags. And from here, we take the top 10 most relevant chunks using ROF score, and we pass this to the retriever.
And so now onto our generator. So our generator consists of four different unique prompts. Starting off with the roles and objectives. So this focuses on the assistant and how it is a educational tour guide. They're an assistant that uses the exhibit materials and survey info. And we set the temperature to zero point 0.3. And what temperature is, it's a number you can set from 0 to 1 to kind of control for how random the output is. So in our case, we set it as zero point 0.3. And then the itinerary, the prompt instructs it to break it down into 7 to 10 minute chunks following an introduction, context, personal reflection, engagement, and wrap up format. The talking points focuses on the themes, techniques, class subject, and major background, and formatted in bullet points with artwork references. And finally, get the engagement tips. This uses the age of the group along with the major background for tone, and then also including one interactive activity. And the temperature here is set to 0.7, a little bit higher than the other three, just because we wanted the output to be more creative for the tour guide. And now on to evaluation.
There's a couple of different sections that we evaluate, but the first one is our topic tagging. So originally, we wanted to compare it with human label data to see if the LLM is kind of matching that reasoning and what we kind of wanted to do. But unfortunately, just due to time and resources, we weren't able to get a labeled data set. So instead, we actually just used tagging consistency as a proxy for the LLM's performance and its competence in its tags. So what that looks like is we just ran multiple independent tagging trials using the same inputs and compared the LLM's labels. So if the labels between runs were very similar, it indicates it's very competent in its tagging. But if it's not as similar, maybe it's more uncertain, it's more ambiguous, maybe they're not quite sure which one is applicable to that chunk. The actual metric we use for that is something called Jakar similarity. So this just measures the overlap between tag sets across multiple different runs. And this was used to kind of guide our model's improvement. And we were able to go through prompt iteration. So we added some clarifying instructions and additional context. So we provided it with some more terms about the art pieces, like what the different types of ceramics are. We added that into the prompt to improve its performance. We also refined the tagging list from the original list. So we removed some redundant ones and the ones that like the LLM seemed to be struggling with, we were able to refine that list using this. And then next for our retriever, we also use LLM as a judge. So this is when you ask another LLM, we use Gemini in this case, to rate the relevance of a retrieved chunk. So you just pass in a text as well as the survey query, and then you give it a kind of scoring rubric. So from 1 to 5, how relevant is this chunk? And then it returns a score as well as some reasoning behind its score. And this was used to build a testing framework to find the best model configurations by using the average score from our LLM as a judge.
We also evaluated the generator. And so the way we did that was we generated 13 different user personas, ranging from typical UMAG tour guide, tour groups, but also some more unusual guides. And we also used an LLM as a judge using the same ranking system. So 1 to 5, 5 being highly relevant. And as you can see, most of the personas did relatively well, falling between 4 and 5, with the range being the different types of users. And so looking a little bit closer at this criteria that we were measuring, the generator performance on. There's topical alignment, tone match, subject fit, personalization, length appropriateness, and this also did relatively well, ranging from 4 to 5, with notably the topical alignment being very high. So a higher topical alignment means that the responses were directly relevant to what the tour guide inputted in their survey. And so this is an example of one of the outputs. So this is an art history major, and looking at their itinerary, the the itinerary included an opportunity for the art history major to have a personal reflection on like the craftsmanship and the global impact of Ming and Qing ceramics. That's just one of the examples. And then we also tested it on a business major. So we related, it says to relate the popularity of enameled porcelain to the cost and suitability for personalized commissions. It talks about the different social classes as well. And then finally, we tested it on a chemistry major. So it highlights the essential for like the clay making process, the chemical process behind tin glazed earthenware. So you can see the difference in how the generator is output. And so these are some of the notes from the evaluator. So some of the strengths, again, with strong topical alignment, engaging and age-appropriate language, along with personalization with the guide majors, like seamlessly weaving it into the response. And some of the improvement was inconsistent acknowledgement of the notes section. So if you remember back into the last part of the survey, the last notes, and then surface level integration of majors, and also some missed niche topics. And we noticed that this was usually when we selected many topics of interest and the generator didn't know what to prioritize given the time and the duration. And so some things we changed, we added explicit instructions. So we added detailed instructions to guide the tone, structure, and narrative flow. And then also added some concrete examples. So included any clear metaphors and topic-specific prompts to scaffold this creative connection. We also removed few-shot learning, so any examples within the engagement tips, because we found that the generator tended to rely on the examples we gave it instead of being creative. And so through this, we found that LLMs do still struggle with creativity. And so we wanted this tool to be more of a creative aid and a guide for these guides instead of an end-all be-all. And now onto the project summary.
So for the past 14 weeks, some of the things we've been able to accomplish. So we started off with project scoping. So we were able to meet with UMEG and visit HKU in Hong Kong to understand a little bit more about the museum, the exhibits they have, how the museum is structured, as well as meet with education curators and museum directors to really understand what are some of their pain points, what do they want to improve in the museum. And from there, we were able to build a technical solution to address those problems and identify a way to integrate it into their current museum. From there, we built our RAG pipeline and our model, and as well as evaluation frameworks to evaluate it. We also built out a front-end user interface that they can enter and test out. And lastly, we also met with UMEG to gather some feedback on our product. We also chatted with some museum guides from UBC here to get some feedback on what are some ways we can improve our product, as well as limitations that could be addressed in future work.
And we'll talk about the global implications of AI now that we've worked in both Hong Kong and our perspective here at UBC. We'll discuss the similarities and differences. So at UBC, they're very interested in exploring and leveraging this technology within the museum experience. However, there are some ethical implications of generating this cultural knowledge because Indigenous culture is so significant here. Having like an LLM generate this knowledge and generate this response can be quite problematic. Um, at HKU, they're also very open and curious and interested in integrating this AI. They see the potential for education, accessibility, and engagement, but there are some concerns and they are pretty cautious on the truthfulness of the responses and what is being shown to museum visitors. And this just shows that AI is not a one size fits all solution. The same technology can be viewed very differently depending on the cultural context and the community perspective and trust in digital tools. And so some future considerations we looked into. We would love to incorporate a feedback loop. So having the notes from the evaluator being fed back into the generator prompt to kind of have one more like checkpoint before responding and generating for the tour guide. And then also incorporating any human in the loop testing. So having real tour guide feedback further refine the output. And with UMAG's constant update and their exhibits, having an easier, more streamlined way to integrate these exhibit booklets into our pipeline, and then further improving the survey integration and having the response be more refined with the survey inputs and notes. And so our project impacts, we wanted to enhance the museum engagement to educate our communities on art and culture, while also empowering volunteer guides, no matter their experience, to teach their community. And finally, integrating safe and ethical AI in education. Thank you so much for listening.